We're on problem set 1-4 and we are on number 10, quadratic and linear function problem. Let f and g be defined by f of x is equal to negative x squared plus 8x minus 4 with a restricted domain from 1 to 6. G of x is equal to 5 minus x with a restricted domain from 0 to 7. So letter A, on the same screen, plot the graph of y is equal to f g of x. Sketch the resulting graph showing the domain and range. So before we do that, first we have to get f of g of x. So what is f of g of x? Okay, going back to the basics, we have g of x is 5 minus x. So g of x is equal to 5 minus x, and our f of g of x would then be equal to f of 5 minus x. And so graphing both of the functions, this is, as you notice, this is a quadratic function and this is a linear function. So let's first graph the function which is quadratic. So its restricted domain is on is from 1 to 6. So we'll make a table. Okay. Let's say we have a table here. And let's do all of those values in the domain. We have all the values in the domain. That's from 1 to 6. Okay, so this is x. So this is your x, and this is the y. Or in that case, that's the f of x. So we have x from 1 to 6. 1, 2, 3. So we're okay. 4, 5, 6. When our x is equal to 1, then our f of x will be equal to negative, parenthesis, 1 squared plus 8 times 1 minus 4. So that's 8 minus 5, so that's 3. If x is equal to 2, that's negative 4 plus 16 minus 4. So that would be 16 minus 8, so it's 8. If x is equal to 3, that's negative 9 plus negative 9 plus 24 minus 14. So that would be negative 9 plus 24 minus 4. So that's negative 13 plus 24. That will give us positive 11. If our x is equal to 4 this time, we will have negative 16 plus 32 minus 4. So that's negative 20 plus 32. That's 12. If our x is equal to 5, that would be negative 25 plus 40 minus 4. So that's negative 29 plus 40, that's positive 11. It's positive 11. If our x is equal to 6, that would be negative 36 plus 48 minus 4. So that's negative 40 plus 48. That's positive 8. Okay, now we go to the second one. Okay, this is our f of x, by the way. The first one is this is our f of x at the restricted domain from 1 to 6. Now we're going to graph the g of x. So our g of x has a restricted domain from 0 to 7. From 0 to 7. So I'm creating the places for 0 to 7. Okay. So let's say this is our x and this is our g of x. So g of x from 0 to 7. Okay, so if our x is equal to 0, then our g of x will be equal to 5. If our x is equal to 1, that's 4. So it's descending by a difference of 1. 3, 2, 1, 0, negative 1, negative 2. Now we are going to graph the g of x and f of x first. So, okay, we will have this grids appearing here. And actually I have already prepared the graph. Okay, it's here. So let's put it somewhere comfortable. Okay, something like that. Okay. As you can see in the graph, in the graphical illustration, this thing here, this would be our f of x. So this quadratic curve here, the parabolic curve that you can see. And this one, the linear function that we have here, the linear graph that we have here, is actually our g of x. So from here, going to negative, that's from x is equal to 0 to 7. Now it says that on the same screen, okay, on the same screen, so on the same screen, we're also going to plot the graph of y is equal to f of g of x. Well, you can do it with your own grapher. So if you plug in y1, let's remove the grid now. Okay, if you plug in y1 in your grapher, okay, if you plug in y1 or y, let y is equal to your f of x, and your y1 would be equal to your g of x. So on your grapher, plug in y of y1, and it will have this corresponding result. As you notice, in our illustration, the same graphical illustration, as you can see here, that I already have the blue dots. Now, what are these blue dots for? If you have a grapher, you will know that this is the graph of your f of g of x. So I initially laid out all of these points here. I already plotted the points. I made it my own algebra, but you can use the grapher for now, okay, to confirm if my graph is similar to what you get on your grapher. So I will connect all of the points here. Now we have the new graph, which is the violet colored curve. It's still a parabolic curve because later on I will demonstrate that the f of g of x that we're going to make is actually a quadratic function also with a new defined domain. So this is our graph for the new function. That's for our new function f of g of x. Now using our grapher. So this one. Okay, now let's move on. Show that f of g of 3 is defined, but g of f of 3 is undefined. So using the same equations, using the same functions, we have f of x is equal to negative x squared plus 8x minus 4 under the restricted domain of 1 to 6. And g of x is equal to 5 minus x with a restricted domain of 0 to 7. Now, we have to get f of g of 3. What is our g of 3, by the way? So our g of 3 first. Well, when you talk about the inserted value 3, it still is in the domain of our g of 3. Okay, so look, notice that our 3 here, particularly the number 3 here, okay, is still in the domain of 0 to 7. It's still in this domain. So we're going to find out if that is defined. So what is our g of 3? That's equal to 5 minus 3. That's equal to 2. So I'm going to highlight 2 here. And then what is our f of g of 3? F of g of 3 would then be equal to f of 2. And f of 2 is equal to negative 2 squared plus 8 times 2 minus 4. And that's equal to, what is that equal to? That's negative 4 plus 16 minus 4. That's equal to negative 8 plus 16. So we have is equal to 8. Now, why is it defined? Let's take a look. As you can see, our new domain now is 2. That's why you can notice that I underlined 2 there. Now, this 2 here is included or within the domain of our f of x, because our restricted domain for f of x is from 1 to 6. So it's still included in the domain of f of x. That's why it makes f of g of 3 as a defined value for this f of g of x function. What about g of f of 3? So we will get f of 3 first. Our f of 3 is equal to negative 3 squared plus 8 of 3 minus 4. And that will give us negative 9 plus 24 minus 4. That's actually simplified is negative 13 plus 24, and that will give us 11. Now let's take a note, take a particular note about this f of 11. I mean this value f of 3, which is equal to 11. Okay, we will not go further to g of f of 3 computations. Why? Because as you can see, our f of 3 is 11. And for us to define the g of f of 3, so that will be equal to g of 11. And as you notice, 11 is not within the restricted domain of our g of x. So it's not in here. As you notice, the restricted domain for g of x is from 0 to 7 only. So our 11 here is not included. Therefore, making g of f of 3 as undefined. Okay, because this is not included. So therefore, g of f of 3 is undefined or does not exist. In your grapher, it will show an error thing if you all take note, and if you all have to consider our restricted domains for both f of x and g of x. Let us see. Find the domain of f of g algebraically and show that it agrees with your graph in part A. So remember our graph in part A. This one, let's take off the grid to make it more vivid. Okay, so that's our graph. This is our graph. Okay? Okay. Now let's take a look for f of g algebraically. Okay, we still have our g of x, which has the same restricted domain, and we have our f of x with the same restricted domain. Let's see. Our g of x is equal to 5 minus x. Our f of g of x would be f g of x. That would be our f of g of x. And our f of g of x would be equal to f of, what is our g of x? 5 minus x. So f of 5 minus x. So that will give us a computation which is of totally a different domain. Now, I've told you before that there are computations, there are steps to be followed in getting the domains of the new, or the domain of the new function, the composite function. So let our f of x or f of g of x, which now in case is f of 5 minus x. So 5 minus x, that looks like s. So we're going to, let's do another one. So 5 minus x should be in between the domain restriction of f of x, which is 1 and 6. And we get rid of our 5 here. So we subtract 5. The same is true with the other side. We will have to subtract 5. So negative 5 plus 1 equals to 5 minus x minus 5 and 6 minus 5. So we are now canceling 5 here on the middle. So we've got negative 4, negative x, and 1. If we got a negative on our middle part, we need to get rid of it also. Okay? So we have to divide by negative 1, negative 1, negative 1. And dividing by negative of the middle will also mean that we have to change our sign for both of the sides. So we have 4 now here, and we have -1 here. Meaning our newfound domain, now is equal to -1 x 4. So this is our newfound domain.